Hey, and welcome to this lesson on the conjugate root theorem. This lesson's objective: apply the conjugate root theorem to write polynomials from given roots. So instead of getting polynomial and finding the roots, we're going to be going the other way. And the essential question: how do irrational and complex answers affect our ability to solve a polynomial equation? And below you'll see the common core standards. So the conjugate root theorem, it's pretty simple. Big, long, confusing, scary words, but actually very simple. If your polynomial has rational coefficients, then any roots that have a radical or imaginary numbers will also have roots that are conjugates of the known radical or complex roots. Remember, a conjugate is the result of writing a sum of two terms as a difference, or vice versa. So that may be a little confusing, but it's actually quite simple, and I'm going to explain it for you. So pretty much all it's saying, you might see a problem like this one on the board here, is that, if I have a root, so first of all, it says write a cubic polynomial that has these roots. Well, I know a cubic polynomial has how many roots? So it's degree 3, so 3 solutions. Well, I only see 2 here. Well, using the conjugate root theorem, I can say that 3 plus the square root of 2 is also a root. So if I go ahead and do this, write a cubic polynomial that has these 3 roots. Well, I'm going to start off here with x equals 1. I know that's a root, so a factor, if I solve for 0, has to be x minus 1. So there's one factor. Now x also equals 3 minus the square root of 2. Now if I solve for 0, I'm going to have x minus 3 plus the square root of 2 equals 0, so that's another factor. And I'm also going to have x equals 3 plus the square root of 2, which is going to give me x minus 3 minus the square root of 2, also equaling 0. So I'm going to take those 3 factors, and I'm going to write the polynomial in factored form. X minus 1 times x minus 3 plus the square root of 2 times x minus 3 minus the square root of 2, all equals 0. Now, just like with any factor, if I had 2 times 3 times 6, in order to find in order to find the product, I need to multiply all the factors. So 2 times 3 would be 6, 6 times 6 would be 36. Well, I have to do the same down here. So the first 2 I would multiply are these 2, because you're going to see something pretty cool happen. These radicals will actually add to 0. So let's do our due diligence, and we're going to start with this first term, and we're going to multiply it by every term in this factor over here. So x times x is going to give me x squared. X times negative 3 is going to give me minus 3x. And x times negative square root of 2 is going to give me negative square root of 2 times x. Now I'm going to take the second term, negative 3, and multiply it by everything in the other factor. So minus 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And negative 3 times negative square root 3, square root 2 is going to give me, I wrote the radical too soon there, it's going to give me negative 3 times the square root of 2. Okay. Now, finally finishing up here with square root of 2. Square root of 2 times x going to give me positive square root of 2 times x. Square root of 2 times negative 3 is going to give me negative 3 times the square root of 2. And I just realized I made a mistake over here when I multiplied negative 3 times negative square root of 2. It should have given me a positive 3 square root of 2. Okay, and so if I go back to the square root of 2, I've got one more thing to multiply it by, and that's negative square root of 2. Whenever you multiply two square roots together, so square root of 2 times the square root of 2, I can simply write that as 2. And don't forget, it is positive times a negative, so minus 2. Interesting thing happens. Look at my terms with a square root in it. They are opposite of each other. So negative 2 square root of 2x plus the square root of 2x, they will add to 0, so they will essentially cancel out. And positive 3 times the square root of 2 plus negative 3 times the square root of 2, they will also add to 0 and essentially cancel out. So I'm left with x minus 1 times x squared minus 3x, which is minus 6x, plus 9 minus 2, which is essentially plus 7. And one more time, I have to multiply x minus 1 times this this quadratic that we just found. And so x times x squared is x to the third. X times minus 6x is negative 6x squared. X times 7 is 7x. And then negative 1 times x squared is negative x squared. Negative 1 times negative 6x is positive 6x. And negative 1 times 7 is negative 7. To combine like terms, I'm going to get my final polynomial, which I will put in blue, x cubed. So minus 6x squared minus x squared is minus 7x squared. Plus 7x plus 6x. I got those two terms. Plus 7x plus 6x is plus 13x. And don't forget minus 7. And that is your final polynomial. So as was said before, this applies to your roots with radicals and also imaginary numbers. So if I'm given 2 minus 3i, you bet your bottom dollar that according to the conjugate root theorem, 2 plus 3i is also a root. So just like with the radicals, it's the same with imaginary numbers. So I'm going to go through the same exact process. So x plus 4 is a factor. X minus 2 plus 3i is a factor. And x minus 2 minus 3i is a factor. Just like I said in the other one, it is easiest to multiply these two first so that we can get those i's to cancel out, just like we got the radicals to cancel out. So I'm going to have, I'm not going to write that yet, x times x would be x squared. X times negative 2 would be negative 2x. X times negative 3i would be negative 3ix. Negative 2 times x would be negative 2x. Negative 2 times negative 2 would be positive 4. Negative 2 times negative 3i would be positive 6i. Go to our third term, 3i times x would be positive 3ix. 3i times negative 2 would be negative 6i. And 3i times negative 3i would be negative 9i squared. Well, let's start to combine like terms. I got x squared, that one's taken care of. I have a negative 2x and a negative 2x. They're going to equal negative 4x. I have a negative 3ix and a positive 3ix. They're going to add to 0. I've got a 6i and a negative 6i. They're going to add to 0. I've got a plus 4 and a minus 9i squared. Right now you might be thinking, hey, Mr. Beagle, you said that all the i's would disappear. Well, you also might be thinking I squared is equal to negative 1. So therefore, I can incorporate that. So plus 4 minus 9 times negative 1. Negative 1 times negative 9 is positive 9. So 4 plus 9 is 13. I can take my other factor and multiply that in there now. X times x squared is x cubed. X times negative 4x is negative 4x squared. And x times 13 is positive 13. 4 times x squared is positive 4x squared. 4 times negative 4x. I'm sorry, this should be 13x. So yeah, 4 times negative 4x is minus 16x. And x times, 4 times 13 is positive 52. So x cubed, we got that one. Let's combine some like terms, negative 4x and positive 4x, they will cancel out. 13x minus 16x, it's going to give me minus 3x. And my constant term is 52. There is your polynomial. And that's all for this lesson. I hope you really learned something. Go apply it to your homework. If you have any questions, feel free to reach out to me. If you still don't understand, go back through the video, come to me. I can show you some more resources. And I hope to see you in live class where we can get into this in a little more depth.